This is the two-way ANOVA video summary. This video is intended as a big picture summary of how to perform a two-way ANOVA. As with any statistical analysis, you should begin with visualization. In this context, visualization means to picture the pattern of data within each cell. The methods for doing so are no different from visualization in the one-way ANOVA, and include box plots, histograms, normal probability plots, and so forth. The analysis strategy begins by selecting the predictors. Since this is a two-way ANOVA module, I assume you've identified two categorically scaled predictors. Once you've selected them, the first model you should fit includes an interaction term. If this interaction is both statistically and clinically significant, we've called this a qualitative interaction, you should stop and base your report on the pattern of cell means. If not, you should refit a main effects model. Within that main effects model, you can report results for each parameter separately, not essentially different from how you'd make a report for a one-way ANOVA. As a reminder, this is the definition of an interaction. As will be the case throughout this course, the model that you ultimately select should follow the principle of parsimony. That is, it should be as simple as possible, so long as it fits the data sufficiently well. Models are compared using partial f-tests. In general, as you're making a decision about whether you should include a covariate as an additional predictor in the model, two possible reasons to do so are to increase precision and to reduce or eliminate bias. The latter rationale applies to unbalanced designs, which typically result from observational studies. Things to report include your analysis strategy, the cell means plus estimates of their variability, and your assessment of interaction. Statistically significant, you should also assess clinical significance, which then creates a fork in the road. If the interaction is statistically and clinically significant, you focus on the pattern of cell means. If not, you should focus on the parameter estimates and the standard errors and the main effects of each of the predictors. Finally, you should report R squared, the proportion of variability that's explained by your model.